Hello and welcome to this first video on TD channel. Today we're going to cover Introduction to Programming. My name is Rudy Cortez and I am going to be guiding you through the next couple of courses. So, Introduction to Programming, what are we going to cover today? On today's topics, we're going to cover some simple programming concepts, just try to ease you guys into what programming is all about. Then we're going to cover a little bit data types, which are the basic building blocks of most programs that you're going to write. And then we're going to move a little bit into operators, which are a necessity to be able to do any kind of computation. So, as an artist or as a CG user, a lot of people will ask themselves, what can I do with programming? Well, for starters, you will be able to create more complex mathematical expressions. With a little bit of recipes and a little bit of knowledge of programming, you'll be able to write expressions to handle all sorts of different animation needs. You will also be able to automate repetitive tasks. If you find yourself doing certain things over and over in the same order, you will be able to write simple scripts that will allow you to do this at a fraction of a time. And from that point on, anytime you need to do that kind of task, you'll be able to just go ahead and run your script. You will also be able to build frameworks. Think about an auto-rigger framework or a debris generator framework, a combination of scripts that when put together and when run will allow you to do work in a very consistent manner, and it will allow to hide a lot of the, let's call it, technical nastiness so that other people can just use it with very simple commands. You will also be able to create something like, for example, exporters. Like if you need to export a camera from one package to another. I know that there's several exporters out there, Filmbox and a couple of other formats, but sometimes you might have to roll your own because you need some extra information or you need to handle things a little bit different. In that case, you'll be able to write it with programming. You could also write something for instance, for exporting animation if you need to. You'll also be able to write scripted tools. Let's say that you need to create something like an edge loop or an edge ring selection or a bridge between edges. You'll be able to write this with a scripted tool. And then finally, one more thing you can do with programming would be to develop plugins. This is not all you can do with programming. Of course, with programming, the sky's the limit. It all depends on how gifted of a programmer you are. But for a day-to-day use in CG production, this is pretty much what you're going to need. So, the one thing that most artists ask me all the time, whenever I tell them that they should learn a little bit of programming, they ask me if programming is rocket science. And the simple answer is, it is not. You don't have to be a rocket scientist, you don't have to be extremely brilliant to be able to program. The reason for this is that programming is not really about math, calculus, or physics. Even though you can use math, calculus, physics, or whatever you want or you need inside of programming, it's not really what it's about. Programming is all about logical thinking, and this is something that a large percentage of us can do. You know, pretty much you can string together thoughts in a logical way and then be able to go through those thoughts. That's pretty much what programming is about. Because at its core, programming is the controlled execution of operations. You pretty much are telling it first do this, then do that, and if this happens this way, do this. If not, then maybe do something else. For instance, let's go into a little bit of an analogy of how you would translate something from real world into the software world. And as a good example, let's start with something like a refrigerator. In the real world, the refrigerator would probably run something like this. While plugged into the outlet, first check the temperature. If it's too warm, then start the engine, the compressor, to start dropping the temperature. If it's too cold, then stop the engine. Then we're going to wait for 1 more minute, and then we're going to start over again. We're going to check the temperature. If it's too warm, start the engine. If it's too cold, stop the engine. That's pretty much how a refrigerator might run in real life. Let's take a look at how this might work in the software world. In software, you would probably see something like this, and this little piece of code here is not real code. You can't compile it and try to run it, but it's just trying to get you guys used to how things look a little bit inside the software program. In software, you will do something like while running, and then you will start this area between these two curly brackets. That's called a block. So while running, you would do check temperature. If temperature is greater than max temperature, start the engine. Else, if temperature is lower than minimum temperature, stop the engine. Wait 1 minute, and then this little part right here, this area, will continue to run. I hope that was clear enough. It's a little bit of a simplification of how things could be, but that pretty much should give you an idea of how programming works. There's a lot of problems that are very easy to translate from the real domain to the programming domain. Now let's take a look at data types. Data types are the core of programming. So for instance, if you're trying to write a program, you're definitely going to need to have numbers. And for numbers, we usually have integers and floats. You'll also need characters, which are single letters, or string, which is a collection of letters that you can use for file paths or names of objects and things like that. You will also, a lot of times you will use or need arrays. An array is a collection of objects. They're also known as lists. And finally, sometimes you might need a hash or a dictionary. A lot of times, and there's a lot of languages that you can get by without using those, but in most modern programming and scripting languages, you do have those, and they're extremely useful. So let's take a look at integers. Integers, as I mentioned earlier, are numbers, and they are whole numbers. These are numbers that have no decimal precision. So for instance, 1, 3, 3,486, these are all integer numbers. Some things to keep in mind when dealing with integers is that all integers operation will return an integer. And this can be particularly catchy or might surprise a couple of, some people when you're trying to use them if you're trying to use a division. So for instance, if you try to divide 5 divided by 2, the result of that will be 2 and not 2.5 like most people would expect. The reason for that is that these two numbers here are integers, so the result will be also an integer. Even though in real life it's 2.5, what most programs do and most computers will do is they will round this number down to the next lowest integer. So in this case, from 2.5, it will round down to 2. Let's take a look at float nows. Float are numbers with decimal precision. They're extremely useful, especially if you're writing to an image that has like a half float or a float precision. Operations between floats always return a float. Operations between a float and an integer will also return a float. And finally, if you try to convert a float to an integer, the result will be the next smallest integer. Like on the previous example, we saw 2.5. If you converted that to an integer, it would become 2. Next down is character and string. As I said earlier, character is a single character, a, or a 1 character, or a 0 character. And sometimes these are very useful. And a string is a collection of characters, something like name, last name, a much longer and complicated string. As I mentioned earlier, strings are used a lot in file paths and in object names. An array or list. An array is a collection of data types. Some languages will allow you to mix data types inside an array. Others won't allow you to. Languages like C will tell you if you are making an array of floats, all the components of that array must be a float. But other programming languages, such as Python, will allow you to mix and match. It will allow you to put a float, a string, an integer, a boolean, whatever you want, or even objects, and we'll get to objects sometime down the line. It will allow you to put all of this inside the same list. A lot of languages, they force you to predefine how big an array will be so that they can allocate that in memory. Don't worry about that at the moment, but most scripting languages are dynamically allocated, which means they will grow and shrink as they need to. Hash or dictionaries, they are extremely useful if you need to store relational information because they have a key and a value. So for example, if you're trying to store someone's data, someone's information in a list, you could do something like list equals John Smith and then 32. The problem with this is that things will always have to come in on this precise order. You will know that the first element of your list is the first name, the second one is your last name, and then after that is the age. If for some reason these objects, these pieces of data here are passed in a different order, then your script will behave very, very erratically. For things like this, sometimes it is better to use a dictionary, which allows you to put these little pieces of information right here, which are called keys. So for example, in this dictionary, you'll have something like name equals Joan, surname equals Smith, and age equals 32. So now let's talk a little bit about constants and variables. Constants are just a value, and you can use this anywhere in your programs, and sometimes they're extremely useful, although they can be a little bit catchy once in a while, and you guys will see why a little bit later, and they can be used freely throughout the program. Variables are symbols. They are aliases that store some data. So in this case, for example, to go back to the refrigerator analogy, you would have something like minimum temperature equals 32. Maximum temperature equals 45. This way, you don't have to remember in your head 32 or 45. You just know that you need to use minimum temperature or max temperature. And as long as you use these two symbols throughout the program, you can very quickly change the values by changing this 32 here to, I don't know, 28. The value of the minimum temperature will change throughout your whole program. While if you were using constants, like just a number, then you would have to track down through all your program and every line of code, you would have to track down where you type that 32 number. And it is extremely hard to maintain code that way. So let's look a little bit of variable properties. Let's start with the names of variables. Variables cannot start with numbers or special symbols. So for example, the first two elements right here, the first two variables, are bad because this one starts with a number and this one starts with a plus sign, which is usually used inside of programming. You are allowed to use one special symbol, which is the underscore. Most programming languages will allow you to do that. So you can do this, or you can just give it a regular name, like my variable. Some other properties of variables is that you can override a variable. So for example, if you initialize a variable like var a and you give it a value of 1, and then somewhere down in your code, you type var a again and you give it a value of 3, you've officially overwritten the value of var a, and now from this point on, var a will have a value of 3. Some languages, like typed languages, and we'll cover a little bit of that later, a declare variable must always hold the same data type. So for example, if you initialize variable b to be 1, which is an integer, and then later on you're trying to assign a string called hi to variable b, this will probably throw an error. Not all programming languages do this, but there's a lot of them that you have to tell it ahead of time what kind of data is going to store the particular variable, and it has to stay in that data type. So at the root of it, you just really need to get comfortable with variables because variables are essential. Without variables, programming would be pretty much impossible. It would just be so hard to keep track, and especially it would be so hard to maintain. So let's take a look at operators now. Operators are used to conduct mathematical operations and computations, but we've looked at a lot of slides, so let's just do a little bit of coding here. So I have my shell here. For this exercise, I'm going to use a language called Python. A lot of you guys have probably heard about this, and if you're in a Mac or a machine that has Python installed, usually you can just type Python, then hit enter, and it will take you to this, which is known as the interactive shell. In here, you can type any kind of Python command. So, as I was saying earlier, you can use constants. So, for example, you can do 2 and then plus 2. If you hit enter, the result is 4. Most programming languages will support all operators, so you can also do 2 times 2 is 4 also. You can also try to divide 10 divided by 5 equals 2. And you can also, of course, subtract. You can do 20 minus 15 or 5. Those are the most basic mathematical operations. And as I showed you guys right here, I talked about this earlier. If you try to do something like 5 divided by 2, you'll get a 2. But you know that that is not the correct answer. So usually what you will do is you will take one of these numbers, 5 divided by 2.0. And the minute you do that O, you see your result is now 2.5, which is what you would expect. Let's take a look into variables now. So if I do a variable called foo equals 5, and then I do a variable called bar equals 10, I can do pretty much, because these are variables and they hold an alias to these values right here, 5 and 10, I can just multiply these guys together. So I can do foo times bar, and it will give me 50. Just as that, I can apply any other mathematical operation. I can do foo divided by bar. Oops, sorry. And that will give me 0. Let's do the other way around. Bar divided by foo will give me 2. So as you can see here, I'm starting to use variables. As you saw earlier, if I type here the value foo, let me make my screen a little bit smaller here. If I go ahead and I just type foo again, you see the value is 5, but I can always go foo equals 234, and from this point on, foo will contain that value, 234. Let's see what other kind of operators we can conduct. There's logical, and this is for a chapter a little bit farther down the line, but I just want to cover them really quick. There are things called logical operators. So I can do foo equals, and pay close attention that I have double equals here. If I do foo double equals to bar, I'm trying to compare these two numbers. Sorry, I had an indentation here. Let's go. If you try to compare them, it will tell you that they're not the same, because foo is 234 and bar is 10. If I do bar equals 234, and then I do is foo equal to bar, remember I'm using double equals, that means you're testing for equality. If I hit enter, you'll see that it will tell me that it is true. So, as I mentioned a little bit earlier, this right here, that's considered a character, and this right here is considered a string. Now, for most programming languages, a string will just be a collection of characters, an array of characters. So if I try to assign this to a variable, for example, if I do my string and I give it hello world, now every time I use my string, I can do print my string, and it will just print hello world. Now this my string here, like I said earlier, is like an array, so you can access the elements of my string like an array. How do you access elements of an array? Let's look at that really quick. So I'm going to do my array. And on this particular language, I'm using Python. Arrays are bounded or limited by these square brackets. So if I do my array 1, 2, 3, 4, 5, this is an array that has 5 integers. So if I do my array and I tell it to give me the object that is on position 0, it will give me 1. Now, you see, most programming languages, the arrays or the list, they always start with an index of 0. So if I tell it index of 0, it'll give me 1. Likewise, if I tell it give me the position number 4, it'll give me 5. If I try to access something higher than that, like 5, it will give me an error, because this element only has 5 elements. This array here only has 5 elements, and since things start on 0, this is index 0, this is index 1, 2, 3, and 4. So 5 doesn't really exist, therefore the program will just throw an error. Let's do an array with different components. So if you do my array equals high to 3.45, and let's do Bob. Right? So that's simple. I can access my RR. What is an RR? Little typo there, sorry. If I do give me element 0, it will give me element the first one, which is high. And if I tell it to give me the last one, it will give me Bob. And the last one should be 4. No, last one should be 3. then it'll give me Bob. A little bit later, we'll cover more information regarding arrays. For the time being, let's move on over to strings. Like I said earlier, if I do my string, it's hello world. To the computer, hello world is nothing but a collection. You can think of it as an array like this one, where the first element is the H of hello, the second one is the E, the L, then the space. So with that in mind, you can always access the individual elements of your string. So if you do my string 0, this will give you H. And then if you do 1, E. And then 2 will be L. This is sometimes useful because you can do certain operations to parse through strings. Like, for example, if you know, if you're trying to find an extension of a file, usually what you're going to do is look for the latest period in your string and then return all the elements that are after that point. This is something that we'll cover a little bit later in strings, but that's usually what you could do to find things out. So this is going to be pretty much all for now. We'll pick it up later. I don't want to bombard you guys with too much information. I know that this feels a little bit tedious and boring, but we really need to understand these concepts before we move forward. So once again, if we sum up, remember that you can create variables. Foo equals 5. You can override a variable. Foo, if I print foo, it's 5. You can override a variable by doing 10. Foo equals 10, and now foo is 10. You can do foo plus equals 20. So you see this plus equals 20? It's a little bit of a shorthand. If I do foo now, you'll see it's 30. This foo plus equal is pretty much the same if I reset it back to foo equals 10. This foo plus equal is pretty much the same as if you were doing foo equals foo plus 20. So this line right here and this line right here are pretty much the exact same thing. Now foo should have that value. Once again, you can compare values between different variables using the this logical operator where you're comparing things for equality. So if you do foo equal bar, it will give you false. Once you have an array, my array, those are all the components of your array. And remember that in an array, you can access things by using an index. Usually, they always start with a 0, and if you go past the last array, this will result in an error. And finally, strings in most programs, in most programming languages, strings are also stored as a collection of characters. So you can very easily do my string, access the first element, and then access any element in your string. So this is all for now. We'll do another video a little bit later where we're going to cover a little bit more about arrays and a little bit more about the different things you can do. And we're actually going to start programming. For the time being, I just wanted to cover some of the basics. Thank you very much, and talk to you guys later.